Well, Mr. Allard here. We're going to talk Unit 2, Module 6, Lesson 3 on names and formulas of ionic compounds. This is going to be a two-part series, so this is part 1 where we're just going to focus on the formulas. So let's get cracking. So like I said, part 1, how do scientists determine the formulas of ionic compounds? In part 2, we're going to address how do scientists determine the names of ionic compounds. So we better get moving. All right, so with an ionic compound, there's so many ions in the sample. So if you have a sample of sodium chloride, you have cajillions of sodium ions, you have cajillions of chlorine ions, and they're all clumped together in that repeating pattern, that crystalline lattice that we've talked about before. Okay, but here's the thing. We don't want to write a billion sodiums and a billion chlorines. So what we do is we reduce that down to its simplest whole number ratio, which we call a formula unit. So sodium chloride appears as a 1-to-1 ratio between sodiums and chlorines, so we just write NaCl. So a few other examples are magnesium chloride. Magnesium chloride is a 1-to-2 ratio, so we have 1 magnesium for every 2 chlorines. And the reason why is because magnesium is a 2+ charge, and chlorine is a -1 charge. So what we need to do is we need to balance their charges to 0. So we need 2 chlorines to balance out the 2 positive of the 2 positive charge of the magnesium ion. Okay, some other examples include potassium bromide. Potassium bromide, potassium's +1, bromide's -1. So they're already balanced, so that's a 1-to-1 ratio. If you look at something like aluminum oxide, aluminum is a 3+ charge, so we're going to need 2 of those to bump that up to a +6 charge, because oxygen is a -2 charge, or a 2- charge, and so that adds up to -6 in order to cancel out or balance out the +6 over here. Okay, so you can see how we have to balance those charges, and we'll see that in the rules later when we go through those. Okay, so a monatomic ion is a single atom ion. So mono means 1, and so if we have an ion that only has 1 atom in it, so 1 element, that is a monatomic ion. Okay, and this table shows us what the different charges are for those monatomic ions. And we already know this because in our first lesson of the unit, module 6, we saw this image here, where the first column we said was +1, the second column was +2, so on and so forth. So those would form monatomic ions, and we would already know their charges. Okay, what happens is those monatomic ions are going to form compounds. And so you take a monatomic ion and a monatomic ion, come together, they're going to form what's called a binary ionic compound, because you got 1 and 1 together makes 2. So binary, bi meaning 2. Okay, so how do we name those, or how do we write the formulas rather, for those binary ionic compounds? Well, we always write the cation first. Okay, the positive ion goes first. That means we write the metal first and then the non-metal second. Okay, so cation first, anion second. The subscripts represent how many ions we have in that compound. And if the subscript is 1, we just don't write the 1. It's just understood to be there. Okay, and like I've said before, the total charge of all the atoms in that compound must equal 0. Okay, so that's why we had to balance out those positive and negative charges, is because they have to equal out to 0. So let's go ahead and try an example here. We have to determine the formula of an ionic compound that's formed between potassium and oxygen. So we got potassium and oxygen. Our first step is to find them on a periodic table. So we have potassium over here, we have oxygen over there. Remember that the first column are +1, so potassium is going to have a +1 charge, and oxygen is going to have a 2- charge, because this is a 1-, this is a 2-. Okay, so we need 2 of these potassiums to balance out the 2- charge here. So I'm going to write the final formula as K2. Oh, remember it's a subscript to represent that I have 2 potassiums. Okay, so go ahead and pause the video at this point and see if you can solve this one between aluminum and sulfur. Okay, I hope you were successful at that. Let's take a look at the solution here. So we have aluminum ions and we have sulfide ions. Notice it's IDE. We're going to learn about that when we talk about naming ions, but that just means it's from sulfur because it sounds like sulfur. So we got sulfur, we got aluminum. Looks like aluminum is going to be a +3. Sulfur is a 2-. Okay. And in this case, how do we get 2s and 3s equal to each other? We got to bump it up to 6. So if we multiply aluminum by 2, we get +6. If we multiply sulfur by 3, we get -6, and they balance each other out, and there's our formula. Okay, so what happens if we have a polyatomic ion? A polyatomic ion is an ion that's made of more than one atom. Okay, so you can see that, like in the case of ammonia, we have nitrogen and we have 4 hydrogens attached to it. So that's a total of 5 atoms in that single ion. And we can identify polyatomic ions because they're going to be ions that have multiple capital letters. They have more than one capital letter in them. So this has nitrogen and hydrogen. This one has phosphorus and oxygen. Okay, so how do we deal with polyatomic ions? Well, it's actually pretty easy because they all have names. And we just look them up on a chart and then we write their name. Okay, or we look up their names and we write their formulas. And so you actually have this in your Pretty Purple packet on page 2. At the bottom of the page, you have this whole table of polyatomic ions that we're going to use in this class. So here's the rules for writing our formulas with polyatomic ions. Well, since we have polyatomic ion exists as a unit, you're never going to change the subscript of that polyatomic ion. What we mean by that is, let's say that we have sulfate. Sulfate is SO4 2-. So if I'm going to write SO4 in a formula, or in the formula, I'm going to keep it as SO4. Okay, I'm not going to change that 4 to any other number. Now, what happens if I need more sulfates? So if you need more than one sulfate in your formula, you're going to put parentheses around it, and then you're going to put how many you need on the outside of it. So let's take a look at a couple quick examples here. So we have sodium and nitrate here. Sodium's a +1, nitrate's a -1. How do I know that nitrate's a -1? Because I looked it up on the table, and I saw that it was a -1. And so those charges already balance out, so we just need sodium nitrate. And so we write the Na and the NO3 next to each other, and we're all good. Well, in the case of barium nitrate, though, barium's a 2+ charge, nitrate's still a -1, so we're going to need 2 of those nitrates. So I write my barium, I write my nitrate as NO3, because it's still an NO3, but I need 2 of those. So put parentheses, put a 2 outside, and we are good to go. All right, go ahead and pause the video, see if you can solve this one here. Looks like we're doing calcium and phosphate. Okay, I hope you were successful at that. Let's take a look at how to solve this. First of all, I'm going to look up calcium. I'm going to see that calcium is in that second column, so it's a 2+ charge. And then I'm going to look up phosphate. Oh, here's my phosphate. PO4 is my phosphate, and it's a 3- charge. So I have a 2 and a 3 again. How do you get 2s and 3s equal to each other? That's right, bump it up to 6. So calcium 3. We got to multiply the 2 by the 3 to get to 6. And we're going to have phosphate. Remember, phosphate is PO4. So I have to keep it as PO4. But I need 2 of them, right? So I'm going to put parentheses and then 2. And I'm going to put a big block around my answers so that I know that's my answer. And there we go. Okay, so like I said, we're going to continue in part 2 on the names. And I look forward to seeing you there. Thank you again for watching. I'll see you in the next one.